Let's go through LeetCode 2008 maximum earning from taxi. For this question, it gives us endpoint and also the two-dimensional array that is the rides. And for every ride, it have a start, end, and a tip. So for this ride, it will have the profit that is end minus the start plus tip. So for those kind of ride, right, we cannot have overlap. So for example, if we have ride this, then we cannot select this, right? In the meanwhile, if we select this, we may not select this chip, right? And it asks us the maximum profit. For the question, we'll see 3, 10, 2, right? For this kind of range, it will have a profit that is 10 minus 3 plus 2, that is 9, right? And he can select 3.2, also 10, 12, 3, right? That means if for one of the interval, the end is another chips start, he can select both, right? So what we think about is that we can sort this kind of right by the end, right? By the end, that is so that the right is sorted by the end. So for example, we have right. Let's use another color. Right like this, and it may like this, right? And I may like this. So the first one end at here, second one end at here, and the third one end at here, fourth one end at here. So we can create long DP, right? Long DP means DPI or mean for the I strip. For the I strip, if we decide to choose it or not, the maximum profit we can earn. So we know for this DPI, the minimum profit, it will be, that is, if we iterate this right I, right, it will be at least DPI minus 1, right? So that means for this chip, we do not take it. So it will be at least DPI minus 1. So if we take it, that means that there may have some overlap. For the previous chips, for example, if we have overlap, we'll get rid of that, right? So if we take DPI, then we'll from this start trying to find the J, okay, DPJ, which end is smaller equal to this start. Okay, so DPI, let's write, let's say DPI will be max, DPI minus 1, right? That means we do not take this chip, or we find a DPJ, right? DPJ. We can use well, how to find this DPJ. We'll talk this a little bit. That is the one which the biggest one which ends before or equal to this start, plus this and I minus start I plus tips I, right? So we just need to have the maximum of these two. That is the DPI, right? In the end, what we need is just get the DP. For example, if this is length, right? If there are k rides, or R right. We just need to find the DPR. So how can we get the DPJ? Because this right, they already sort by the end. And for every start, we know this start. We just use a binary search. We'll find the largest index, which is smaller equal to start R. So let's begin to write code for this. Let's first sort the array right by the end. Arrays sort right. Here we have A and B. We sort by its end, that is the integer compare A1, B1, right? Then we are going to, because this is the long type, right? Let's have how many lengths of it. So int length equals right dot length. So we are going to have long profit, right? We are called dp equals new long length, right? That means for the let's write dpi is for the ice chip, right? We max earning. So we know for the initial one, the first one, right? dp0 equals right we can actually if we don't in this case we return dp length -1. We can have one actual length for this because I'll talk about this while we'll do this later, and so that dp0 will be 0 because we want to find the largest index, which may be which may be small equal the start. So if there is no such right, and we can use dp0 equals 0, right? So we have an actual index here. So we'll say dp0 equals 0. So we'll say for int I equals 1, I smaller than length plus 1, I plus plus. We know for this dp I, it will be at least dp I -1. So the worst case, right, that is we do not take this right. And there are another scenarios that we need to find the index, which is the large index, which is smaller equal to this start. We'll have, let's do this. Right. Equals right. I -1, okay. So we'll have int start equals right there, right. we'll have int j equals get max index. Okay, get index of rights and stuff. Okay, that is the maximal index. Max index which have a right which have n right and index smaller to start. So in this case, we know DPI will be max DPI -1, and that is we do not select this right or DPJ plus right right one, that is the end, right, and minus start, and also we need to have the is cheap, that is the right two, right, and in the end we just need to return DP max. And because this kind of right, they already sort in by the end, so we can write a private in find called get index. Okay, get index. That is the max index of right have the n index smaller or equal to starts, and we are going to have this one right and target like that. So we do back research here to find the index. Length equals right length. So we know we are search the index int start equals 0. And equals length 1, right? Plus a while and start plus 1 smaller than n. Int equals start plus n minus start divided by 2, right? So we are going to find the maximal, right? So that means if need right, okay, right, need this index. If this its end, if its end is equal to mid, equal to target, right? That means it is possible that there still have some index after this mid, which will reach the start, the target. That means we need to search on the right part. So we'll have a start equals mid. So if same, if this one smaller than target, right? That means we need to find this index in a large range, right? So we'll say if this is right, 1 is greater than target, then we'll have n equals mean, and we can have this condition as else. Okay. Else. So here the binary search we have the index start and end, right? That assume that we always find the right smaller which have the end smaller equal to target. But the thing is that it is possible for this kind of range. Here we're trying to find the largest, right? So when we jumping out to the binary search, the start is one that index before the end. So we need to conclude that if the end meets the condition, the end is what we search. Then we're trying to see if the start meets the condition, then start is what we searched. But the thing is that it's still possible start and does not meet the condition, right? That means we cannot find the largest right, which is somewhere equal to target. So in that case, the start is 1, is 0, right? And this is 1. So if we cannot find, we just return -1. That means, and also we do something like this is that because we, just as we mentioned, we can have an initial value dp because this one has one index shift to the right. If we cannot find a one, right, then the j will be -1, right? J will be -1. Then here this is the right index, right? So in this case we add one more. For dp we shift one to the right. So we'll say we have dp 0 here, and dp 0 the default value is 0. Right. So we are trying to see if right and because we want to find the largest index which is somewhere equal to target, right? Somewhere equal to target, then we return and let's say if right start 1 somewhere equal to target, then we return start. Otherwise, we just return dimensional. Okay. So this is should be right. Let's take some other examples. So I don't think this aim is used in this question. And for this question, if there are lengths right, we have a slot. This will be length log length operation. And here, this will be an ON operation. And also for this ON, we try to find its maximal index. This is also log n, right? So this is also log length. So this is the O length log length. This is also O length log length, right? So it seems that it's n city is not being used. So yeah, and yeah, so we have a space that is linear, right? So that is the O length.